What is a covalent bond? Recall that an ionic bond is between a metal and a nonmetal. Alternatively, covalent bonds are between two nonmetals.
Remember, metals are on the left side of the periodic table, and nonmetals are found on the right side of the stair step, with the exception of hydrogen, which is on the left side but is considered a nonmetal. This means all elements in covalent bonds are on the right side of the stair step.
Covalent bonds form so that atoms will have access to electrons which fill their outermost shell, making them more stable. They are different from ionic bonds because covalent bonds share electrons instead of transferring them.
For example, when oxygen and sulfur bond. Oxygen is found on the right side of the periodic table and has 6 valence electrons. Oxygen is a nonmetal. According to the octet rule, oxygen will become more stable by having access to 2 or more electrons so that its outermost orbital is full. Remember from the Lewis dot structure activity, only the bonding electrons can transfer or share. The paired electrons already have a buddy, therefore cannot be separated. Sulfur is also on the right side of the periodic table and has 6 valence electrons. Sulfur is a nonmetal and needs access to 2 more electrons to become stable. If oxygen gave up its 2 unpaired electrons to sulfur, the sulfur would have a full outermost shell. But oxygen would only have 4 electrons, which would not satisfy the octet rule. Similarly, if sulfur gave up its 2 unpaired valence electrons to oxygen, the oxygen would have a full outermost shell, but the sulfur would only have 4 electrons, which would also not satisfy the octet rule. Instead, in our example, the oxygen and sulfur will share their 2 valence electrons, which are not already paired. Note that both atoms have a full outermost orbital, making them more stable. The sharing of electrons creates an attraction between the 2 atoms, which is strong enough that we call it a chemical bond. This type of bond is a covalent bond. We will discuss what this bond looks like next class, but a summary of it will be on the next slide. Please pause and write it down. But if you look at the example that I have on the bottom here, sulfur will share 2 electrons and oxygen will share its 2 electrons. So the 4 electrons in the middle are forming a double bond between them.
There are 10 covalent prefixes which you will need to know. These will be used in the compound name to represent the number of atoms of a specific element. Can you think of everyday items that use these prefixes? Tri is used in tricycle because there are 3 wheels on a tricycle. Octopuses have 8 legs, so they use the prefix octo. A hexagon has 6 sides, so it uses the prefix hexa. A decade is 10 years, so it uses the prefix deca. Pause on the next slide and make sure you write these down in your notes.
Now write covalent naming on your paper and draw a line underneath it. We are going to work with the compound B2O3, so write that underneath the line. Then write step 1. Identify the first element and how many are present using the prefixes. Similar to ionic naming, you keep the name of the first element the same as it is on the periodic table, except for now you include a prefix. For example, if 2 boron are in the compound, you would write diboron instead. Next, write step 2 on your paper. Identify the second element and how many are present using prefixes. You will still change the suffix to IDE, just like you did in ionic compounds. In the example, you have 3 oxygen, so you will use the name trioxide. Tri is the prefix for 3, and you had 3 oxygen. All right, so then you need to write step 3, put it all together. So we're going to write it the way we found it. So we have 2 borons up there, so it's diboron. And then there are 3 oxygens, so it's going to be trioxide. And remember to change the suffix at the end of oxygen to "ide." So our complete answer is diboron trioxide.
Next, we're going to do some practice problems. All 3 problems will appear on the next slide. Pause the video and try all 3 in your notes. Once you have completed all 3, continue on and check your answers.
Our first example is this covalent bond. Now, our first atom, carbon, there's only one of them, and we don't use the prefix mono if it's the first element, so we can just write carbon. Our second element, chlorine, there are 4 of, so we need tetra as our prefix, carbon, tetra, and then we have to change the suffix, so it's going to be chloride. Our second compound is with 2 hydrogen atoms and 1 oxygen atom. Since there's more than one of the first element, we have to use a prefix, and that prefix will be di. So this is dihydrogen. And we just have 1 oxygen because it's the second element. We have to use the prefix mono. So we've got dihydrogen monoxide. Our last compound is with nitrogen and sulfur. We've got 2 nitrogen atoms, so we're going to use dinitrogen to begin. And we have 5 sulfur atoms, so we need pentasulfide for our second part. As you do these problems, double check that you're giving the right suffix for your second element and that you're not using the mono prefix if it's for your first element. If you need any help with these because you're having a hard time, see your teacher before the next time you have class.
All right, there are a couple rules to remember, so be sure to write these down. First, if there is only one of the first nonmetal, don't use a prefix for that element. So for example, if I had CO2, do not write monocarbon dioxide. It would actually just be carbon and then dioxide. You still keep the prefix for the second element, but since carbon only has 1, you don't have to have a prefix for it. The second rule, you do not need to reduce the subscripts like you did for an ionic bond. The compound formula is showing the actual quantity of the atoms in the compound. You will write what is shown in that compound. For example, N2Br4 is dinitrogen tetrabromide. It should not be reduced to NBr2. It stays as it is.